we need to find the formula that helps us find the slope of the tangent of any function at any point. It has this form, x of x. It could be any value, really. 2, 3, 4, 5, it doesn't matter. What we want to calculate is the slope of the tangent line. Let me draw it. The slope of this line, the tangent line. Now, to do this, I'm going to draw a second point, point 2. Doesn't matter where it is, really. It just can't be in point 1. It could be here, here, doesn't matter. Now, with this point, I'm going to draw a secant line. An important thing here is that the distance between point 1 and point 2 is h. So, if this is x and this is h, then this would be x plus h. This h is also called the increment in calculus. So now we can say that point 2 has the x-coordinate of x plus h, and the y-coordinate would be f x plus h. If we can go back a little, we can remember that if we approximate point 2 or approach point 2 to point 1, we can get the slope of the tangent line with the slope of the secant line. So, with that, we can say the following. We can say that as point 2 approaches point 1, then the slope of the secant line approaches the slope, which is m, of the tangent line. There's another way of saying this exact statement. If we go back to the graph and we imagine point 2 approaching point 1, we can also see or imagine that the space h would get smaller and smaller. And if it gets smaller and smaller, then wouldn't it be approaching 0? With that in mind, we can say that as h approaches 0, then the slope of the secant line approaches the slope of the tangent line, which is the same result as the previous statement. And these two are equivalent. Now, moving forward, let's talk about the slope of the secant line. We know that to calculate this slope, the formula is y2 minus y1 divided by x2 minus x1. So let's calculate that. We know that y2 is f x plus h. So it would be f x plus h minus y1, which would be fx, over x2, which is x plus h, minus x1, which is just x. Let's continue. The slope of the secant line is equal to fx plus h minus fx. The denominator changes because if we subtract x of positive x, it eliminates itself. So the denominator would only be h. Let's remember that we're looking for the slope of the tangent line. So we're done with this process. Now, what can we say about the tangent line? We can say the following. We know that to get the slope of the tangent line, we need to approach the slope of the secant line. So we can say that the slope of the tangent line is the limit when h approaches 0 of the slope of the secant line. We already know that the slope of the secant line is fx plus h minus fx over h. So what we do now is just substitute. The slope of the tangent line is equal to the limit as h approaches 0 of fx plus h minus fx over h. My bad. This should be in brackets instead of parentheses. It makes it easier. Moving forward, let me make a little division here. Now, I'm going to establish the following sentence or statement. Let's represent the slope of the tangent to the function at a point x by the following term. F prime x. What this means is that this entire phrase, the slope of the tangent to the function at a point x, is represented instead by f function, a function prime x, or just simply stated as f prime of x. We can read it this way. The slope, this little symbol, of the tangent to the function at the point of x. So if we can say that f prime x is the slope of the tangent to the function at point x, then we can also say that f prime x of x is equal to the limit as h approaches 0 of the slope of the secant line, which is fx plus h minus fx over h. And this would be the formula to calculate the slope of the tangent of any function at any point. I can read it the following way. F prime of x is equal to the limit of as h approaches 0 of this quotient, which is the slope of the secant line, f x plus h minus fx over h. So what did we learn today? That this is the formula that we use to calculate to find the slope of the tangent of any function at any point.